This video is for lesson 5.2 and probably I'm going to do just examples 1 and 2. Okay, so in this one we are verifying trigonometric identities. So you're going to want to have your formula sheet handy. These are the identities, these up here mainly, that we're going to be verifying. So kind of show you what a problem looks like. I'm going to apologize in advance for all the page flipping I have to do. This first example, I'm going to leave it up to you. This one is not a real urgent one that needs to go into your notes, but if you want to put it in your notes, then pause the video and copy it. So this is kind of an example of verifying. So for example, this is asking for what angle does the sine of that angle equal 0. So we know that's here at the angle 0 because this point right here is over 1, up 0. So the sine is, looks like I need a darker pencil. I'm going to switch to my pen here. So the sine is 0. Now, if you think about it, that's going to be true for pi over here also, where I'm at -1, 0, and then again at 2 pi, and if I keep going around at any multiples of pi. So the way we write that is we say it's only true when you have pi times an integer. So 1 pi, 2 pi, 3 pi, 4 pi. The integers are whole numbers. So we're verifying that it is true that sine of x equals 0 only when x is some integer multiplied by pi. Here's another kind of for example one. This says, on the other hand, an equation that is true for all real values of a domain is an identity. So again, they're saying the ones on this formula sheet are true for any value of x. So for any angle, the sine squared plus the cosine squared equals 1. And if you haven't rewritten these in their other forms, all I did here was say for this one, if I want to get cosine alone, I would minus the sine squared from both sides, and then I would get this. This is just another form of this identity. So you can do algebra on these. If I want to get sine squared alone, I would subtract cosine squared from both sides, and then I would have this. Same thing here, if I wanted to get tangent alone, so tangent squared of x would be equal to, I would minus this 1 from both sides, and this would get me secant squared of x minus 1. So you can do algebra on these. So this is one of them. This comes from this one, sine squared plus cosine squared equals 1. But they've done that minus cosine from both sides, and they have this. So this would be true for all values of x. All right, so there are some kind of recommendations or steps you should follow when you are verifying or when we get to solving problems. So here are some things. First thing says work with one side of an equation at a time. So I'm just going to quick show you our first example. This is our first example right here. So when they say work with one side of the equation at a time, I would probably say, okay, I'm just going to see what I can do with this side, keep going until I get it to match this side. So in general, you don't want to work on both sides. And in general, it's often best to work with the messier side first. Look for opportunities to factor, add fractions, square a binomial. That means multiply a binomial out using FOIL or box method. Do some algebra on these things, or the adding would not even be algebra. So this is kind of like simplify whatever you can get. Look for the opportunity to use these identities. Like these are going to come up a lot. These are going to come up a lot also. So you want to be on the lookout for those. Like whenever there's sine squared or cosine squared, tan squared, secant squared, the 6 trig functions squared, probably you're going to use one of these Pythagorean identities. Okay, when the preceding guidelines do not help, try converting all terms to sine or cosine. This is very often going to be a strategy that you use. So just because it's number 4 doesn't mean you're not going to use it a lot. When I say when you can't think of anything to do, write everything as a sine or a cosine. And this is the biggie. Always try something. There isn't one method that I'm going to be able to teach you that's going to work. So you're just going to have to get used to maybe not knowing where to start, but trying something. It might not work. You might fail, and then you try again. All right, so this is our first example. So this is what you want to, example 1, definitely put in your notes. So if you need to, pause the video and copy that problem. So what I want to show is that I want to rewrite this. This is how I'm going to do this. I want to see what I can do to this side to get it to equal this side. So I'm just going to mess with this side. And right away, I see that secant squared, secant squared. So remember I said, whenever you see the squareds, you want to think, I'm probably going to be using these Pythagorean identities. Okay, so what do I have here? I have a secant squared minus 1. Well, we already kind of wrote that. We said if I wanted to get tan squared by itself, I would minus 1 from both sides. So then I have tan squared of x equals secant squared minus 1. So remember, if you're just looking at this, identity, you don't see secant squared minus 1, but you can get the tan squared by itself. You can minus 1 from both sides. So then this whole numerator here, I can simplify into tan squared. Theta is just a different way of writing the angle. If you want to write an x, you can. So I'm going to rewrite this. Secant squared minus 1 is tan squared. And then on the bottom, I'm just going to keep that secant for now. And remember, I want to end up with a sine squared over here. All right, so now I have tan squared and secant squared. So what I might think in this step is write as sine and cosines. So sine of theta and cosine of theta. So I said that's often what you're going to do. So remember, tan is the same as sine over cosine, and secant is the same as 1 over cosine. Doesn't matter that these are squared. I can write tan as sine squared of theta over cosine squared of theta. And then, so this is what tan became, sine squared over cosine. And then secant squared is the same as 1 over cosine squared of theta. Okay? So that's looking good. This is one of those deals where I have a fraction divided by a fraction. So I want to do the keep, change, flip, keep the first fraction. So I'm just going to copy sine squared over cosine squared, keep, change to multiplication, flip the second fraction. So the cosine squared of theta goes on top and the 1 goes on the bottom. Okay, now if you think about this fraction as one big fraction, I have a cosine on the top and a cosine on the bottom. Those divide to give me 1. So now I have sine squared of theta times 1, which is just sine squared of theta, which is what I set out to verify. So I am done. All right, so that's kind of how they go. You just have to try some stuff, which you're going to try some stuff now in this. Hang on, let me get to your turn. All right, so this is the one that you're going to try. So I want you to write that down and pause the video and then come back and look at the solution. You need to try these on your own. Please, 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 please don't just copy it and not try it first. Okay, so hopefully you tried it. So I worked with this side of the equation. I said sine squared plus cosine squared is equal to 1. That is one of our Pythagorean identities. So that was the first thing I did. And then the bottom, I also said, oh, cosine squared, I can't do anything with that. Now I'm going to do that strategy where I write everything as a sine or a cosine. Secant squared, I can write as 1 over cosine squared. Okay, keep going. If I multiply these two right here, right, this is like cosine squared over 1 over cosine squared. So I end up with cosine squared over cosine squared. If I'm dividing two things that are the same, I get 1. So I get 1 over 1, which is what I set out trying to verify, that all of this was equal to 1. The other thing I want to mention is sometimes there's different ways to verify these. So if you did it different, as long as you didn't make a mistake, then you might verify using a different method. Okay, example 2. So pause the video, write that in your notes. Okay, so this one of the strategies or one of the steps that they recommended in the front was to factor or add or multiply. This is an addition. So I want to actually do this addition. And again, I'm going to work on this side, work on the messier side, see if I can end up with the 2 secant squared over here. So in order to add fractions, you need to have a common denominator. So the common denominator is going to be just this binomial times this binomial. So my common denominator is going to be 1 sine of, I don't know, what is that, an alpha? I don't even know what that is. It's just going to be those two multiplied together, right? It's kind of like if you have 1 over 7 plus 1 over 2. The common denominator here would be 14, or just 7 times 2. So I'm just multiplying those together. Okay, so this fraction right here has the 1 minus, but it's missing the 1 plus. So I want to multiply the top and bottom of this fraction by 1 plus sine. And then I want to multiply the top and bottom of this fraction by 1 minus sine. You can kind of think of it as doing this crisscross. So this I need to multiply up here. This I need to multiply here. So what I end up with is, I don't know if I need that parenthesis, but I put it 1 plus sine of, I don't know what that is, alpha, plus 1 minus sine of whatever that Greek letter is there. Okay, so hopefully I didn't lose you there. Again, think of this. If I'm doing, my common denominator is 7 times 2. This fraction already has a 7. It needs a 2. That would be 2. This fraction already has the 2 on the bottom. It needs the 7. So I'd end up with 2 plus 7 over here. So, right, that would be 9 over 14. Just did the same thing here. Okay, now I can actually do the addition. I want to add or combine like terms up here. So it looks like I have a 1 and a 1. So 1 plus 1 is 2. And then I have positive sine squared. I'm just going to call this x. Positive sine squared of x and negative sine squared of x. So if I combine like terms, those add to 0. So I'm just left with a 2 there. Okay, now on the bottom, probably I want to do this multiplication because I'm still not seeing how I'm going to get to this sine squared. So I want to multiply this out. So remember, you could do a box, although I don't really recommend. I recommend you use foil on this. If you're doing a box, this is what you would do. And then this would be positive sine of x, and then you would fill in your box. But I'm going to do FOIL on this. I'm going to do first times first. 1 times 1 is 1. And then when I do outside times outside, 1 times sine of x would just be sine of x. Inside times inside would be 1 times negative sine of x. So that'd be negative sine of x. And last times last, 1 positive and 1 negative, so that'd be minus sine times sine is sine squared. Now you notice these inside terms, 1 positive and 1 negative, those add to 0 or cancel out. So now I'm left with 2 over 1 minus sine squared of, I'm calling it x. Okay, now your brain should be going, oh, 1 minus sine squared of x. That's a Pythagorean identity. Right here, we wrote 1 minus sine squared of x. We took this identity and we minus the sine squared from both sides, and we said, oh, 1 minus sine squared of x is equal to cosine squared of x. All right, now we're getting somewhere. So this is the same as 2 over cosine squared of x. Okay, which is kind of the same as 2 times 1 over cosine squared of x, and 1 over cosine is secant. So this is the same as 2 times secant squared of x, which is what I started out trying to verify. Okay, that's a lot. If you need to, pause the video, replay the video maybe. That's the great thing about the video. Kind of digest everything that happened here. We did addition and we had to get a common denominator. And then we had to do multiplication of 2 binomials down here. And so if you did the box method, you still should get the same thing happening. Those middle terms should add to 0. Okay, one more for this video, and it is a your turn. So please put that into your notes and pause the video and try it. Okay, hopefully you paused the video and tried it. So it's an addition one. So I started out doing that same thing where I get a common denominator. So there's my common denominator. There's my new numerator. I had the same thing happening. 1 plus 1 is 2, and these added to 0. So now I have this. 1 minus cosine of beta is sine squared. That's a Pythagorean identity. So 2 times 1 over sine squared is the same as 2 times cosecant squared, because 1 over sine, where is it? Right here. 1 over sine is cosecant. Okay, that is it for 5.2, the first video.